Hi, Mr. Ray here. Hey, I'm introducing a new series of videos using the LEGO classroom programming environment for the EV3. Now, the main goal is to learn how to move the robot around the table with very good accuracy. We will use the gyro, wheel rotations, maybe the light sensors and the walls to accurately position the robot anywhere on the table. We're going to do a quick review of the gyro and calibration series. Then we'll start with a simple drive straight program using the gyro. We will then add the capability to turn and then drive straight. And then we'll make that program into a My block so that it can be used multiple times. We will add the capability to go in reverse as well as forward, as the first My block will only work in the forward direction. And we would like it to work accurately in either direction. Then to further improve the accuracy, we will introduce parallel programming so that we can add a program that will smoothly accelerate or decelerate the robot, so we can move quickly across the table without jerking or spinning the wheels or sliding the wheels. And then we'll talk about a few other things like debugging and the like. The classroom environment is not very easy to debug in that there are virtually no tools to let you see what's going on inside your program. But let's get started, and we'll do a quick review of the gyro and calibration in this introductory video, and then we'll move on to the straight line drive program. So I hope you'll join me. I will make this a series so that there is a single click on my page that you can get that will show you the playlist for all of these videos as I introduce them. And I hope to put one out about once a week. Okay, so the first thing I want to do is just a quick review of the robot with the gyro installed. So I've got a diagram that shows the robot that's facing forward. When a new program starts, the gyro angle is set to 0. Now, if you run multiple missions that come back to the home from within the same program or project in this case, if you want the robot to start with 0 degrees, you will have to zero the angle yourself, but we'll talk about that later. So now sitting here at 0 degrees, if I turn the robot to the left, the degrees will go negative. And if I keep on turning, they just keep on going more and more negative, so that if I come all the way around 360 degrees, it will read minus 360. If I were to go around again, it would read minus 720. And in a similar way, if I go to the right, it will increase positively. And when I get back pointed straight ahead, it will say 360. The direction that means 0 is always the direction the robot was pointing when you started. Now, the exception will be is you can reset the gyro to 0 yourself and establish a new, I'll call it baseline for what 0 is. Let me now move on, and I'm going to talk about the gyro calibration. So I brought this up on just an empty program block, but I'm going to move that now directly to a project that does the gyro calibration. Now, this is discussed elsewhere in another video called LEGO Classroom Gyro Calibration. Now, we'll tell you after I made that video, which discusses more than one way to calibrate the port, that this is the only one that I could get to work for all of the various LEGO gyros. This calibrate routine will do if the gyro is drifting, which means the robot indicates that it's turning when it's sitting still. Then if you run this program, it will reset the gyro so that the angle is not turning. This is a program that was introduced in another video called LEGO Classroom Gyro Calibration. So let's get on to the next step, which we're going to build our drive straight with the gyro program. Okay, so now we have a new canvas up, and I have 3 instructions on the canvas. Is when program starts always comes in when you create a new project. The next 2 are related to the motors. The first one sets my drive motors to motors B and C. This third instruction says to set the brake when the motors stop. And that will do that if I say stop moving, or any one of these others where you specify the number of rotations or whatever it should run. Okay, and now I need to add some variables. Now I've already added most of them, but I'll just add one to make sure everybody remembers this. Remember, a variable can store a value. I can change the value, and I can use the value elsewhere. So I've got one I'm going to call count. Drag this out. And I'm going to set count to 0. Only I got to make it count. Now what count's going to be used for, it is part of a test program, testing the program that we'll do later. And it will, we're going to have a loop of instructions that run in a repeat loop over and over. And this will count how many times it executes. We'll also use a timer later so we can tell how fast our program executes. Now, the other variables, there's 3 of them. There is B degrees. This will be how many degrees the B motor turns while I'm moving. We have C degrees, which will tell me how many degrees the C motor will turn. And I'm using degrees because the sensor for the motors reports degrees. And we'll find out later there's less computation in our repeat loop so that it will run a little bit quicker if I do it this way. The other variable is one I call motor degrees, and this one will hold the number of degrees we want the motors to turn. In other words, how far we want the robot to go. Now, I call it motor degrees, but here I put in a multiply block, and that's because I really want to specify how many rotations, not how many degrees. So this is the number of rotations, and I multiply it by 360, and that will tell me how many degrees. When I make my block later, I'm going to use rotation, not degrees. So now that's just the basic stuff that we need to get started. So I've got some other stuff pulled over here that I'll drag over and we'll use. Okay, the other thing is we want the motor encoder to start at 0 to simplify the process. Now, I'm probably going to change this later, and I'll talk about that in a later video. So I'm going to reset both motor encoders to 0. So now if I read them right here, it would say that motors have turned 0 degrees. I'm also going to use the gyro, and I'm going to use it to drive straight. So I'm going to reset the angle to 0 so that when I do my steering, I'm trying to hold 0 degrees on the gyro. That's basically all there is to getting ready. I believe we've got it all. And I come over here, I've got some more pieces. And we'll take them apart and bring them in. I'm going to bring them all over where I can see them. Now, to use the gyro to hold the position, I want to run the motor and I want to run it in a loop. So I use a repeat until loop. And now then, in this loop, I want the motors to drive the robot until either the B motor is greater than motor degrees or C motor. In other words, one of the 2 motors will have run 3 rotations. This sort of mimics the behavior in the lab view where a move tank or a move steering use whichever motor moved the furthest. And so I want this loop to run until that. So let's see how we built this. So I have a logic block that says if this condition or this condition is true, then this block stops running and exits. And in one of those I have is B degrees greater than motor degrees, just like we just said, which goes in there. And the other one I have C degrees. So now then, this loop will run until one of the motors has exceeded this number of degrees. So now I start the motor moving in the loop, and that should be 0. And I want it to go straight ahead, which I've already set this angle to 0. So if this number is negative, then that means the robot is turned a little bit to the left. And if I tell it to move minus that angle, it will turn toward the right until this angle zeroes out. Now, after I start it moving, then I want to measure how far each motor has gone. I'm going to do that every time I go around the loop. So again, I'll pull one of these out so you can see what it is. So I've got the absolute value function that goes in there. Now remember, an absolute value, if you have a positive number, it will just return a number. If you have a negative number, you will get that number without the negative sign. So I'm going to put the degrees counted in there. So this is going to be how many degrees the B motor is turned. And likewise, this is how many degrees the C motor is turned. So this loop will run until that condition is satisfied. The only other thing I'm going to do is right here, I'm going to increase the count. So each time this loop runs, the counter will click one time. And so when this quits running, for right now, I'm going to stop it moving. And then, so the program will exit. I'll put the stop and exit program. Now let's look and see what we got here. I don't need that. So now I've got the whole program here. So we should be ready to run it at our convenience. So now I have the picture up on the robot, and I will start it. So you can notice that when I disturbed the robot and moved it to left or right, and when I turn it loose, it automatically goes back to the correct position. So that should just about do it for this one. Next video, we're going to make this thing do a little bit more and make a fairly useful navigation routine. That is the end of this program, and if you want to see the remainder of the series, you can look in the LEGO Classroom Navigation series on Raise Robotics, and you can see all the videos that I've completed for this thing. So be sure and subscribe, and I'll look forward to seeing you the next time.